So, if you are a pilot, which got us off on that tangent, and I was just in a Tigger mood. So, yeah. Anyway, by the way, I think I never looked up the origin of off on a tangent, but there is something in calculus called Newton's method.
That's terrifying.
And you know, like how you found zeros by factoring and stuff?
Yeah.
But some things have zeros you would have never been able to find without your calculator. Y'all pay attention, okay? Even though you only need this for, but still it's extremely interesting. So I want you to think about that. Just because you can't factor it doesn't mean it doesn't have an answer. It means it doesn't have a nice sweet answer. That zero might be 1.752936, okay? Which you could find with your calculator. But Newton didn't have a calculator, and they really needed to go ahead with mathematics. So much math was happening, of course, for centuries and thousands of years. I mean, think of how much we still use Pythagoras' stuff. And Newton. And in the late 1600s, so much was happening, but they didn't have calculators. And so they were doing a lot that we're doing without a calculator. And so Newton came up with this method where he would write the equation, which you'll learn in calculus, how to write the equation of a tangent line. And if you write the equation of a tangent line, and tangent, do y'all see what I mean by its tangent to that graph right there? It misses the zero. It didn't make it, okay? But then Newton would fill it back into the equation and write another tangent line. And every time he got a new tangent line, do you see it's taking you closer and closer to that zero? Mm-hmm. So he would write the equation of a line, and he would take a point and fill it into the equation. He'd write the equation of another tangent line, and he would fill the number into the equation. He'd do another tangent line until he just got closer and closer to the real zero. Well, when you learn it in calculus, what's interesting, or if you do it on your calculator now, if you're trying to find this zero, and all of you have probably done calc zero, second calc zero maybe, well, I think we've done it maybe together, not a whole lot. But there's a function on my calculator where I can go to the left of it and the right of it, and it'll find my decimal zero.
Oh, yeah,
okay?
We did this last year, I think.
We did. Some of us did. Depends on who you are and where you were. But if I'm way over here, I'll probably get an error on my calculator because it's actually using Newton's method. It's been programmed to do something that they did in the late 1600s. And so what happens is, do y'all see if I put you on this tangent line, you're going to go off on a tangent and you're not going anywhere close to the zero that you want. If I go over this hump right here, do you see my tangent lines are all taking me closer to that zero? I don't know if y'all see what I mean. But if I'm way over here, I'm off on a tangent. Like I'm not getting close to what I need to be close to. So I'm thinking that's probably where it came from. A little extra math.
Yeah, because if you're off on a tangent, you're not close to it.
You're not close to where you want to be. Yeah. We'll have to look up the history of it, but I think that's where it must have come from. Okay, so now I've been off on a tangent twice. I'm a Nessie and literally off on a tangent with off on a tangent. So now we're in math class, okay, and suppose that you're a pilot and you're circling and you're wanting to land in, and they find there's an emergency flight coming in and they're going to have to divert you to another airport. Say you were going to land at LaGuardia or JFK and they want to divert you to Newark because of something happened, okay? And so suppose you're in the airplane. That's an airplane, okay? You're in the airplane and they figure out, by the way, airplanes turn at angles. They don't do rectangular coordinates like 5, 4, okay? They're not going to tell the plane to fly down here and over here to get to Newark Airport, okay?
It'd be a hypotenuse.
So if they're flying this direction and they compute the angle and they actually tell them to turn that many degrees, you've heard of a heading or a bearing?
Yeah.
Girls, okay? I meant in the air, over here and over here, okay? I didn't mean on the ground. Seriously, because we need to move on, but this is good. This is stuff to make you think about what you're doing, okay? So if they find this angle and they say, oh, that'll get you right to Newark. I mean, obviously this is ridiculous to fly straight this way and straight this way, like I would have to in a car. In a ship or an airplane, all sorts of applications in the real world, people don't use X's and Y's, they use what are called R's and thetas. They wanna know, how do I turn, how far do I go? This is a radius that you're gonna fly to land in the right place. And if they don't give you the right angle or the right radius, you're in trouble, you're not gonna land at the right airport. Okay? You're gonna miss it. So it's real important, even though I've been kind of silly. Alright, girls, based on how this person was flying, their heading would be negative 30 degrees, right? Well, what would you pick? Would you be mad if you were a pilot and they said turn 330 degrees?
Yes.
Everybody might even get sick. They'd certainly be scared if you feel your plane turning 330 degrees. Won't it get you to the same place? Won't it have all of the same X, Y, and R coordinates? So that's an example of both of those would have the same sine, cosine, and tangent that would have helped them calculate this angle. But then I've got to decide which one do I want to give them. Do y'all see what I mean? Okay? And so there's reasons for the stuff that we're learning that are very impactful. Remember that our sine, cosine, and tangent graphs go on and on forever. By the way, soon you'll end up with something like this in an equation. Sort of like that, sine x equals 3, that one's no solution. Never gonna happen. How far does your sine graph go up and down if it's left unaltered and at amplitude 1? Do you see that? Is this sine wave ever gonna hit 3?
No.
Sine is opposite over hypotenuse. Can that be 3 over 1? What does the hypotenuse have to be? Sine's opposite over hypotenuse from your geometry. Doesn't hypotenuse have to be the biggest side?
Yeah.
There's no way for that to happen, is there? By your new trig, by your new stuff, you're graphing sine. The graph of y equals sine x, to review you a little bit for your exam, is going up 1 and down 1. There's no way it's ever going to hit 3. How many times is it going to hit 1/2? An infinite number of times. Actually, girls, there's a way to report all of them. Let me give you an example, okay? Julia, when's your birthday?
July 6th.
Did you notice she didn't say July 6, 2000, what year are you born?
2002.
2, okay? If I got mad at her and said, no, Julia, when's your birthday? Okay, she'd have to go July 6, 2002, July 6, 2003, July 6, I got it. All right, got it. Do you see she told me every birthday she's going to have? Because it repeats every year. All right, Kate, I know, has a sibling, Nancy, and she probably knows her birthday.
Yeah.
Okay, and her mother, Nancy, knows exactly when Kate and Nancy's birthdays are. Okay, so it happens twice per calendar year. When she turns the calendar over, she can record her 2 daughters' birthdays in the same location. So she can know coming and going, backwards and forwards, when their birthdays were. So there is a way to say it, because she just said July 6th, I got it, okay? So we'll talk about that. What about my friend Sharon Erickson, whose anniversary is on February 29th? I got it, but I also understand something else that's kind of funny.
It's leap year.
She only has an anniversary technically every 4 years. So do you see it has a different period? Okay, so if Julia says July 6th, I got it. Okay, smooth the streams, close to 4th of July, it's in summer, blah, blah, blah. If Sharon goes, my anniversary is February 29th, we have a bigger discussion about it, don't we? About, oh my goodness, it's funny, her husband Mort agreed to marry her. They're like, are crazy in love, but he was kind of a funny man, big old funny man. But he's like, yeah, I'll marry you, but I'll only marry you if we get married on leap year. And they did. So that way I only have to give you up. He was totally joking.
Oh.
He's like a big romantic, but he really wanted to do that just to be funny. But I mean, he still celebrates it on one of the other days, but it's just sort of funny. It's just so
I
weird.
hate
so
getting
funny.
married on leap year.
Same, that's so confusing.
Yeah.
Also, I'm just
It is
so
really
about time and space, I'd be so confused.
Yeah, me too. Same, I'm like,
Okay,
it's 5 years.
so
Like, it's married on like a big day.
Like
so
Christmas.
What?
No,
No,
no.
Girls,
no,
looking
no,
at-
no,
It's
no,
so pretty.
it's just
looking at your homework, okay, and hopefully really trying your homework. 5, 7, and 9, you were just filling in and verifying that was true. So if I'm looking at number 9, I have 2 sine squared x.
There's a cup over here with a note on it.
Minus sine x.
It says the word gullible was under the cup.
minus 1, it says gullible?
It
Check
says
it out,
the
Katie.
word gullible is under the cup.
It's just gonna be like, haha, you're gullible. Just
That would
oh
be
my
me.
god, please open it. See the print.
Or
Well,
what
like
if it's a
a-
road?
That's what I was
What if
That's
it's a
not
rat?
But
No,
I
it's
feel
not
like
gonna
it's
be
a
a roach.
joke.
It's gonna be like a
I
post
feel like
that
it's
says,
like,
haha,
it's
got
gonna
it.
be a cockroach.
Just open it. Just open it.
Are you serious?
See, it's
We're
nothing.
so
I told
gullible.
you they were pranking us.
They were breaking us.
Was it nothing
It's
there?
nothing. They
nothing
pranked
there.
us.
Okay,
Surprise.
so this was number 9. Number 9, pi over 2 worked and 7 pi over 6 worked. They look like they don't have anything to do with each other. All right, pi over 2 and 7 pi over 6 both worked. If you go 2 times the sine of pi over 2 squared minus the sine, the sine of pi over 2 minus 1, let's see if we get 0. You should know pretty fast the sine of pi over 2 is 1. Do y'all see sine is y over r? I don't know if I'll ever teach the IOU chart again, because those are the things you're the worst at. Not you, my honors pre-calc class too. The past few years I've just sort of not wanted it. I don't use the IOU chart. I know sine is y over r, so it's easy for me to know sine of pi over 2 is 1. Sine of 3 pi over 2 is negative 1. Cosine is x over r, so I like to see it in my head. By the way, sine of pi is 0. Look at this, girl. Sine of pi, is there any y coordinate over there at all? Do you see how sine of pi is 0? Because there is no y, okay? So you'll see me doing that more and more with these things. So this is 2 times 1 squared minus 1 minus 1. You get 2 minus 2, you get 0. Hopefully you really did that and it worked. Then when I fill in 7 pi over 6, really ugly, okay? The sine of 7 pi over 6, you see why I made you do the memo quizzes, because your teacher doesn't slow down now. The sine of 7 pi over 6 is negative 1/2. Sine of 7 pi over 6 is negative 1/2. That gives me 2 times negative 1/2 squared is 1/4 minus 1/2 minus 1. Sorry, right here I messed up. Sine of pi over 6 is negative 1/2, but it was behind a negative sign, so shouldn't that be plus?
Yeah.
Alright, so this should be plus. I get 1/2 plus 1/2, so I get 1 minus 1 is 0. Sorry that was so messy. I won't always do it that messy, but they both work. Alright, now let's look at it on the calculator. I'll just do it on Desmos for interest of time. Alright, so it was sine x squared. I think, was it minus sine x minus 1? Let's see.
Oh, these are the teeth.
Yeah, it's the little 2 sine squared x. All right, so 2 sine squared x. And I think I'm in radians. Okay. Now, do you see, like, Julia's birthday, July 6th, things happen over and over again. If I know the period of the graph, there is going to be a way for me to tell you every answer in the whole wide world. Okay? All right, so does pi over 2 work? Pi over 2 gave me 0?
Yeah.
And 7 pi over 6 gave me 0. So those two did work. Their whole point is maybe there's more than one answer. Aren't there a lot of things that will give me 0?
Yeah.
Okay, and I'll teach you how to name those. All right, so are y'all okay on on 5, 7, and 9, where you filled it in and got the answer? Okay. All right, then on 11, it said, they kind of let you off the hook here. Right now, if you'd gone home for homework and said, find all the answers for sine of x equals 1/2, you wouldn't have been able to finish your homework. Because how many answers are there to sign in? On a memo quiz, I could make all 10 of them come out 1/2. I could go sine of 30, sine of 150, sine of negative 210, sine of 390. I can just keep on going around my circle and hitting 1/2. Are y'all okay with that? Okay. So you just should have been really mad at me. However, either if you had emailed me or come by for help, if those weren't options, you probably would have discovered what I let y'all kind of discover on your own the other day. You kind of taught yourself some stuff in some of our investigations that we did. I kind of should give you this, and then you'd come up with some ideas, okay? Because sin x equals, well, first of all, let's answer the question. Then I'm going to go in and show you how to give all the answers in the whole world. So now you'll have to look at the directions and homework and on the test and exam and stuff. You have to read the directions. Your directions said find all the answers on the interval from 0 degrees to 360 degrees. So now we're having to think backwards through our unit circle charts information, and you should be really fast and good at this. I know so many times that the first thing that pops in my mind is that 30-degree angle. And then all students take calculus. Did y'all get 30 and 150 without, maybe you looked in the back? Are y'all okay with that?
Yeah.
All right, so that's done. Sine is only positive from 0 to 360 two times during the first cycle. Alex, can you wait just a minute? This is like the worst time to leave. Because I'm about to teach something big, but then I'll pause in like a minute and let you go, okay? Now I want to turn the calendar and it happens again. What I mean by that is here's a sine wave that hit 1/2 twice. At 30 if I turned it onto Desmos, and 150 if I turned it onto Desmos. And right now, what's the period of sine?
X.
What's the period?
Oh,
2
X
pi.
over.
If I'm in degrees, what would that be?
Yeah, I know. It's 2 pi. Oh my god. Oh my god. Wait, 360.
Anybody,
2
360.
pi.
Thank you, Ava. And she right.
Sorry.
If the period in radians is 2 pi, we don't ever graph in degrees,
Yeah.
but just because we don't, there's no big reason. But wouldn't that be 360 if Ava and I were graphing in degrees? So aren't these going to happen every 360 degrees? This is like Nancy and Kate's birthday. I don't know what they are. But when I turn the calendar, they're, okay, my 2 kids' birthdays. March 11th and June 4th. Turn the calendar.
I really know
Thank
it's
goodness I
fine.
don't have to write them on the calendar because I know my kids' birthdays. But if I was afraid I'd forget, well, some of my good friends, I don't want to forget their birthday. Okay, so if somebody I've just learned their birthday that's a new friend, I might put it on my calendar, and then when I get a new calendar, I can put it on again. So every 360 degrees, this happens. All right, I'm hurrying, so you can. Are you going to the nurse or the bathroom?
No bathroom.
Okay, I'm hurrying. All right, so if I add 360 to both of those girls, 30 and 360 is 390, and I believe that one's 510. Actually, this is not the right answer, okay? Because all it does is find me the next year. I now lost those. Do y'all see what I mean?
Yeah.
So we say stuff like this to tell you that it happens every quote year, every cycle. We say 360K, 360K, where K is any integer.
Can we write that?
You have to write that. Oh, don't, you can just listen or take notes. I'm just sort of giving you a window into what's coming. So Julia said July 6th. I know that was before and after this year, okay? If I flip backwards and forwards. Name me some integers.
7.
Thank you. Name some more.
94.
23. So they're numbers are over 1, right?
Yeah.
Okay, so an integer is where it lands right on the number. 0 is an integer. What about -8?
Yes.
Yes, those are integers, okay? So if K is any integer, that means somebody could come in here and fill in 0 for K. Watch this, girls. If I fill in 0 for K, I get these 2. What if I fill in 1 for K? I get these 2. What if I fill in Ava 23 for K? I flipped over 23 cycles and there they are. Do y'all see that it takes these 2 answers in the first cycle and answers them over and over again? All right, get out your calculators and let's try it. You can go if you'd like. I can.
So you're basically saying that the right answer was 3150 plus 360?
No.
Or no?
The right answer to this question said 0 to 360,
Uh-huh.
and those were the answers to that homework question. Now I'm
You're
building.
just building on it.
Right. Okay. It lets you off the hook.
Okay.
as far as to how many you have to say.
So are we typing this in?
Okay, right now, what mode do I need to be in?
Degree.
Degree. Alright, so y'all in degree mode? Alright, go to your just regular viewing window, not a y equals, but just your calculator window, and type in sine 150.
For X minimum?
No, I'm sorry, you're not on your Y board.
It's just this.
Oh, and you're not really on window, even though I said that word. I mean, you're
That's
just
what I
on your,
meant.
yeah, sorry.
We're just like regular.
Regular calculator, alright. Sine 30, what'd you get?
0.5.
1/2, right? Alright, now do this. Do sine of 390.
1/2.
Alright, what I just did was I added 360 to 30. Now do this. Sine of 150 plus 360 times 23.
Okay.
I took Ava's number 23 and I went 23, for lack of a better word, years into the future, and I'm still gonna be sitting there at 1/2. So I've gotta learn my kids' birthdays, and then I can go backwards and forwards, okay? If I say Clayton's birthday is March 11th, you don't need to say, well, what day was he born? But it'll be March 11th, okay? When's his next birthday? March 11th, alright? So, let's do this. Sine of sine of 30. Now this is what I'm doing, girls. 30 plus 360k. Let's say 360 times negative 8.
0.5. 1/2.
Alright, so this time I took one of my first two answers and I went back this way. Alright, so this is what's happening. Sine of x is 1/2. Right here. It's hard to land on 1/2. I can't grab it. Oh, here. Sine of x is 1/2 at pi over 6, because I'm not in.
You're so slow.
Anya's responses are really bad.
Would y'all agree that those are our two birthdays?
Yeah.
That's where sine equals 1/2. Girls, watch. What we're talking about is there's lots of times that sine equals 1/2. Did y'all see that? Did y'all see these two right here?
I'll be right back.
Here's one, and here's one. Isn't there another one over here?
Yeah.
And another one back here? And is there any end to that? All right, so, I'm sorry, somebody nodded. Let's shake our heads. There is no end. Okay. So, let's put this in here. We'll let Tigger hold it. There we go. All right. So, what just happened is this. I found the ones that were logical to me in the first cycle. I found the 2 times it happened right here. And I'm in radians right now. So if I add or subtract 2 pi to these numbers, if I subtract 2 pi, do you see how it takes me back to that one? And this one takes me back to that one. So it shifts everything back and forth to pi always and forever. All right, I'll come back to that. I'll revisit that. I want to try something on this slide that I think will happen. Let's see.
I want her holding Cheez-Its. She have them? At the bottom. Or should I stay here for a second?
Y'all can do what you need to do, just, you know, if you're gonna be missing something big, but,
I can
maybe,
wait for a second.
this is all like so much, but that's not gonna stop, so if you really need to go somewhere, then go.
No, it's okay.
Okay,
I can
like,
wait for a second.
I don't know if you wanna wait that long. Alright, so, before I do anything else, are there any other questions on your homework? What was the last one I gave you? 31. So did you do 29 also? Let's do 29. 2 sine x plus 1 equals 0. So all of a sudden, without warning you, I started in on what I needed to teach you, and I bet you did okay. All of a sudden, you had to do a little algebra to it before you finished it, right? All right, did anybody look at the answer in the back of the book?
Yeah, I think it was 11 pi over 6.
They
plus
should have done this.
2 something.
There we go. Okay, they were doing what I'm doing, and I sort of
but
let you.
it's in reading version.
Yeah.
Right.
It was like,
I have
Plus 2 pi k most likely, or 2 pi n.
yeah,
Okay.
yeah, I got 2 pi.
Everybody
n.
watch. Now it says solve. It does not, girls, it does not say solve from 0 to 2 pi or 0 to 360. It says solve, always and forever. Give all the answers. Okay, girls? You're supposed to give all of the answers in the whole wide world. You're supposed to give all of the answers of when 2 sine x minus 1, was it minus or plus?
Plus 1.
Thank you. 2 sine x plus 1 equals 0. You got a lot of answers, don't you? Can y'all see all those zeros? And aren't there more off both sides? Okay, that's what I'm talking about. So this is what you're gonna do. And I sort of just threw you out there to give it a try, and you looked it up in the back and at least had part of your answer right. I'm guessing, okay? So I think without any direction from your teacher, I think most of y'all probably subtracted 1 and divided by 2. Did that happen? If it didn't, it needs to. You're now solving trig equations, girls, okay? Now I'm gonna think of the first couple of things that come to mind. Sine is negative here and here. I'm in radians, they didn't tell me to be, I will on a test. Girls, if I don't tell you what mode to be in, then you can choose. And I'll just take either one. I usually will say answer in radians or answer in degrees. I put about all the answers in the whole world, so we gotta start somewhere. We're gonna start with this angle and this angle. This one is 7 pi over 6, and this one is 11 pi over 6. I expect you to be fast at that. You might need to go back and play the radian game some, okay? Now, everybody watch, because it's not true for every function. This function, what is the period of this function? The amplitude is 2, but what's the period? How often will it repeat itself? What's the period of?
2 pi.
It's 2 pi over 1, isn't it? Isn't it 2 pi? So you'll say plus 2 pi. Yeah, I use a K. Your book uses an N. I just use a K because I do that more than others. And then I say where K is any integer. You do technically need to say this because somebody needs to know what in the world you're talking about. In your homeworks, I don't really care. But there are times that I say K is every other integer depending on what it is I'm doing. Okay? Sometimes you'll see answers in the back of the book. They're a little different from yours, but yours might be completely right. So when I'm grading your test, Bryn might say something different than Mia says, but they both might be right. Okay, girls? What I just did was I added the period to the first two. When I say where K is any integer, one of my integers could be 0, which means that gives me these two answers. If K is 1, watch my fingers, it gives the next two answers. Okay? If K is 85, it's gonna take me these two answers plus 85 years down the road. Y'all see I'm marking my calendar with these two birthdays and I add the period of time to it. Okay?
Yep.
For Julia's birthday, it happens every year. For somebody on February 29th, their birthday's every 4 years. Okay? How often is tangent gonna repeat itself? Not 2 pi, pi, just or 180, okay? So do you see what you'll do? You'll add the period to it, okay? So that's why it said that funny thing in the back of the book. All right, now let's go to 31. Because now all of a sudden, I'm starting to do these things with you. All right, on 31,
How do you think they give people with birthdays on leap year like IDs? Like at what age?
I think by the year. I mean, I would imagine.
That's probably really complicated. I think.
No, I don't know. I know when they card people, they usually have like the year up there on the cash
Yeah.
register.
Yeah.
And so you can still tell by the year. But that's a good question. So technically they're not 18
Yeah.
until March 1st that year.
Exactly.
Yeah,
February
if you go out for your
28th, they
birthday
wouldn't be
on-
old enough.
Yeah.
What if you go out for your birthday on the 28th and they're like, no?
You know, be smart enough to wait another day. Okay. Square root of 3 secant x minus 2 equals 0. So you have secant x is equal to 2 over root 3. Sorry, I went kind of fast through that. Are y'all okay with that? Add 2, divide by root 3. I don't mess with secant. I always do sine, cosine, and tangent. So if secant's 2 over root 3, what is cosine?
Square root of 3 over 2.
Square root of 3 over 2, and I'm like, oh, I recognize that. Cosine's positive here and here. Again, some of y'all might need to play the radian game. You need to get really fast at this. And so cosine is 3 pi over 2 at a 30-degree angle. And so right here it would be pi over 6 if you're in radians. And this one would be 11 pi over 6. And then you're going to go back and look at the period of this graph. Isn't it still 2 pi over 1? So you say plus 2 pi k, and then you write where k is any integer. Some students feel like on every problem they're going to write where k is any integer, so they write it at the top of the page. Like FYI, k is any integer, unless I say otherwise. All right? Okay. How's your heartbeat? Are you okay?
Yeah.
All right. Making me a little bit nervous. All right.
I just feel like I have a very high heart rate because my heart rate's at 84 right now.
Is that high? That is really high.
Maybe you miscalculated.
That's not super.
Last
Yeah,
time I
it
went to the
is.
doctor, I was like 90 something. I took like a really high one.
Same, that was so awkward. And then I
I
got
can-
more
I
nervous
can
because
get
they're like,
like
it's probably,
low,
it's probably,
my
it's probably
rest
fine, but we're gonna take it again. And they
50,
took it in like 3 different
56
ways. And then, oh. it
When I was in the
horrific.
hospital, I had complications and my heart rate dropped to like below 40.
Okay, girls, find this worksheet. Find this. We're just gonna kind of move from one thing.
I didn't put,
If you brought it with
online,
you,
yeah.
yeah, that's fine. Did we do this side, the whole side?
Oh yeah.
Yeah, we did.
Yeah.
Okay, then never mind. So
I
I
think
did
we did.
all of these.
Wait, can I see it?
Yeah,
Up
we
close?
did all
This,
this.
which one?
Oh, I'm
we
sorry.
did do
I'm in
that
this
sheet.
side. Did we do all of
No.
the
Yeah,
other?
we
Okay.
didn't do the second side. Also, can I say one thing really quick?
Yeah.
Okay, so my mom made me go to medical camp over the summertime, so we did, and then we
Why
tried
did you
doing.
do that?
Because my mom did. That's not the point of the story. So we were like having like heart rate machines where you put your finger inside. So everyone was like, okay, try to make yours higher, try to make yours go lower. So one kid like made his heart rate so relaxed, and he himself like was like literally meditating, like closed his eyes, and he made it to go like 50s or like high 50s, low 60s, something like that.
Yeah.
But then I was like, no, I'm gonna make mine go really high, and I did, and it like passed 100. So I
Oh
was
my
like,
goodness.
let's load my report card. And then
Let's
like,
load my report.
and then it was like report generating, and then mine like spiked up, and I was like, this is awesome.
That's funny.
So that's just fun.
Interesting. Okay, when I say verify the identities, you're trying to turn this side into this side, okay? When I say verify the identities, it
Oh,
looks
is
like,
this when you can't touch the other side?
yes.
Okay.
Is that
And you have a
only-
quiz on this next class. So we're gonna do a lot of them right now.
Only verifying
It's a puzzle, you already have the answer. I'm
I
sorry.
know.
I'm also in that.
I don't know if I have that. Did we do that?
Didn't y'all
Yeah,
get
it's
this?
on the, it's on the back of the verify
I'm sure it
identities.
I'm sure it's
Yeah, this was from like a couple days ago.
only one was from.
It says worksheet 4.1 at the top of it.
It was so
Yeah.
confusing.
Yeah. We had 10 and 12.
You have
Yeah.
10 and 12 on that
Oh,
page.
yeah.
Okay?
Oh, wait, yeah.
All right, so 1 minus cosine squared is sine squared. Sine 2x, if you still need to look at your memo page, which you won't be able to look at on the quiz, sine 2x is 2 sine x cosine x, which is why we have the memo quizzes. Now, did y'all see a sine squared at the top and a sine underneath it?
Yeah.
It's all multiplied so I can cancel. Sine goes into sine squared and leaves me sine x left over. Okay? So what's sine over cosine?
But wouldn't it be 2 cosine?
Hang on just a minute, Bran. What's sine over cosine? Tangent. Alright, when you cancel, what's understood to be on the top?
1.
So you have 1/2 tangent. Bran, do you see the 2's on the bottom?
Oh.
Okay, so a side note, if I have x over 3y, girls, please watch. If I have x over 3y, that's the same thing as 1/3 x over y. Isn't that a 1 on top of there? So Brandon, do you see what I mean with the 2? The 2's on the bottom. So I did it, okay?
Wow.
Let's go to number 10. Number 10. Okay, 10 is, 12. 12, you had cotangent squared x minus 1 over cosecant squared x equals cosine 2x. Now, many times I say it's best to change everything over to sine and cosine, but it sort of depends on what I see. Hey girls, I do have a cotangent squared x on my memo page.
Yeah.
But if you look, it's cotangent squared plus 1, not minus 1. Did y'all see that? So I can't use it. Okay? So what I'm gonna do, everybody watching, see this word cosine? That makes me think, I better change everything to sine over cosine. Okay? So cotangent squared is cosine squared x over sine squared x, cosine over sine, minus 1. Cosecant squared is 1 over sine squared. Boy, that's really ugly, right? By the way, remember I'm not messing with that. I've shown you this many times, and it's time that you started doing it. This is called a complex fraction. I have fractions instead of my fractions. The fastest way to clear that up is to multiply the top and the bottom by your common denominator. What is my common denominator throughout this problem?
Sine squared x.
Good, sine squared x. And if I do it to the top, don't I have to do it to the bottom?
Yes.
Okay, now distribute. What happens there? What happens to your sine squareds? But what happens?
2 sine squared x and
Whoa, 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 whoa.
Does that
Can't
become
you
2
cross-
sine
This is-
x?
Don't those cancel?
Yeah, that's what I said.
Did y'all see those cancel?
Yeah.
There's one on the top and one on the bottom?
Yes.
Okay, so that gives me cosine squared. And what do I get here?
Minus sine.
Minus sine squared, thank you, great. On the bottom, what happens here?
Same thing.
It's 1.
Cancel.
It's 1, it cancels. Now if you need to, look at your memo page. Somewhere on your memo page is cosine squared minus sine squared. That's why I make you memorize it, though, or you won't even know when you're finished. And also, I'll point this towards you.
Thank you.
Y'all need to know your memo page for memo quizzes. Look at your memo page. Cosine squared minus sine squared is on your memo page. You gotta have it memorized.
Cosine squared.
Minus sine squared is on your memo page.
Where's that?
double angle identity.
Thank you. What does it say it equals?
Cosine to that.
So when Alex runs into cosine squared minus sine squared, she could convert it into cosine 2x, and I'm there. Isn't that what I was supposed to do?
How does the top? How does sine squared x times cos the top part? How does that become cos squared x?
Well, I didn't want to do this because I also needed to distribute that sine squared over there. But the first distribution, do you see that would cancel?
Yeah, but the second one doesn't.
And then that one, I still don't needed that sine squared. It's going to both of them.
Okay.
All right, so it's like I did this, girls. Sine squared x. That's like I did this. I multiplied, watch this, times this one, and do you see the sine squared is going to cancel out?
Yeah.
But then you also multiply it times this one.
Okay.
Multiply it times that one, it's on the top and it cancels out. Okay? All right, now those are the ones I liked best on that page. Let's jump down to 15 though. The reason I didn't give you any more of these is not because I'm nice. It's just because I didn't like the way they were written. And I was afraid you'd get confused. If I gave you number 15 on the quiz, I would write it this way. 2 tan x over 1 plus tangent squared x equals cosine 2x. I would give it to you that way. so that you are not messing with this cosine 2x. Did I copy it down right? Okay. Somewhere in your memo page is 1 plus tangent squared. That's why you're supposed to be memorizing. You're supposed to see that stuff. Just like if you see square root of 144, you think 12 only because you've memorized it. If you don't memorize it, you're not gonna be able to do this, okay? Look for it if you don't know it. 1 plus tangent squared is sitting on your memo page. It could pop up on any memo quiz.
Secant squared.
Secant squared. So I see it, I can't help but write that down. So I have 2 tan x over secant squared x. All right, well that didn't seem to get me anywhere. But I'm glad I have it. What did I say if you're stuck is a good idea to do? Change everything over to
Simplest form.
sine and cosine.
Yeah.
And also, Julia, and I see this word cosine over there, okay? All right, so now tangent is sine over cosine. This 2 could be considered to be on the top with that sine. It's like 2 over 1. And secant squared is 1 over cosine squared. What's the common denominator? Do you see how I have an improper fraction? I'm sorry, I have a complex fraction? So what would take care of everything? What's the common denominator? Not cosine, but I need cosine squared. Don't I? Cosine squared to the top and the bottom. What happens here? I have a 2, I have a sine x. What else happens? This is all multiplied together.
So it becomes 2
Doesn't this cancel?
Yeah.
And leaves me a cosine x right here. What happens here?
It's just 1.
On your memo page somewhere is 2 sine x cosine x. Whoa, hang on. I feel like I copied this down wrong. I did. Look at 15. What did it say it equaled? 15 sine 2x. Sorry about that if you probably didn't write that down because you probably didn't write, I miscopied it. What does 2 sine x cosine x equal on your memo page? Double angle identities?
1.
No, look at your double angle identities. 2 sine x cosine x equals
Sine 2x.
sine 2x.
Or sine 2a.
Well, right now we're following our variable. That's why teachers make you memorize it. If you don't have it memorized, you're just going to be sitting there looking at 2 sine x cosine x. But girls, you can do it. Because what does your brain think as soon as you see sine over cosine? Tangent. Okay? 1 over cosine. Secant. Make yourself learn the most recent ones. If you have to, like, however you memorize history facts. Sometimes I had to make myself flashcards and have somebody call it out to me. Sometimes I had to try to write them from memory and then check my work. You gotta know those new identities. Pythagorean, cofunction, and double angle. They're real important. Okay, now, look at these. Grab one of these. Here, Ava, start these around. We're gonna do a few of these. I'm just gonna start knocking them out and show you how I would work them. And then you can practice some more on your own. If you can do this sheet I just handed you, you'll be fine on the quiz. Well, in addition to the other one. I'll make sure you know what to study, in other words. Sorry, I didn't say that very well. And let's put one on Bryn's desk. Julia, will you? Okay, for Ben. Okay, so number 1. I'm just going to start cranking them out. Number 1 is cosine x plus sine x times tangent x. I'm supposed to make it equal secant x, which I cannot change. I think everybody in here would be dying to change the word tangent, okay? And so I'm going to try that. Cosine x plus sine x, tangent is sine over cosine. Well, that's disappointing. Wasn't I hoping something would cancel?
Yeah.
Okay? If you're trying to add things that don't cancel, this should be your thought process. I'm trying to add those now. I've done what my teacher suggested that I do. So, Mia, what should I do?
Because, I might be wrong. Because cosine x plus sine x. No, I'm going wrong.
Girls, if you're trying to add something that are fractions and nothing cancels, do what you always do when you're adding fractions. Get a common denominator. I'm gonna get a common denominator, okay? What's my denominator? Cosine x. You have to show me every step. What are you gonna multiply this by? Cosine and cosine. No, you know how I get a common denominator? Okay, so I've gotta multiply, it's just like this. 3/4 plus 1/5. What's my common denominator? Don't I have to multiply the top by 5 and the bottom by 5? Okay. So I'm getting a common denominator. And so this becomes cosine what? Squared x. And what's this one? Sine times sine?
Sine squared x.
Sine squared x. And they're both over cosine x. So what I did was I was trying to add fractions. I got a common denominator. And somewhere on your memo page is cosine squared plus sine squared. You
Wait,
should
why did the sine get squared though?
Oh, sorry.
Oh, because you already multiplied it. Okay.
Well, I had sine x times sine x. That's sine squared x. What is it doing? All right, this is bad. Stop.
Maybe press
Hit
escape.
done.
There you go.
Okay. Thank you, Bryn. Well, now everything's gone. All of my markers. That's never happened.
Do file
File.
or no tools, just kidding. But you might be able to open up the tool or maybe edit.
Maybe file, save it, and then quit it, and then open
No,
it
no, no.
again.
You can open up the little toolbox.
Wait, go back to view.
Toolbox.
Toolbar
Yeah,
options.
yeah, toolbar options. Maybe show sidebar. No, what was it? It was the top.
Try
I think it thinks the sidebar showing, but it's not.
Why did you say
Oh,
chop
no,
it
it said
off
full
the
screen
top?
page order. Go back to there.
No.
That's the
Maybe
weirdest
Use
thing.
the tools
Maybe
thing
press
again.
notebook again.
Tools menu.
So
Oh, gosh,
weird.
you're on the beach ball.
Why did it like
No.
just like
And now all of a sudden I only have 1 minute.
Maybe press notebook again.
Or just use the
I'd
tool.
say
Like
file,
the
save,
icon?
and quit
you
it.
could use the whiteboard.
Yeah, but we only have 1 second left. Okay, so I had gotten to this. I had cosine x plus sine x times sine x over cosine x. A lot of times when you change it, something cancels and it doesn't. So this side was sine times sine, that's where sine squared came from. And this is just cosine. It should trigger in your mind, I hate that word, it should make your mind, it should make some key turn to where I'm trying to add this to a fraction, so I'm gonna get a common denominator. Cosine x times cosine x. Now I have a common denominator. This is cosine squared x plus sine squared x. Somebody in this room has found what sine squared plus cosine squared is. 1, thank you, over cosine x. What's 1 over cosine? Secant. What was on the other side of the problem? Secant. Done. Okay, now, what I'm gonna do, because it's time to go, almost. That clock is not right. Oh, it is. Okay, so that clock is wrong. Let's do the next one. All right, let's try number 2. Number 2, and then I'll tell you what I'm gonna do. Number 2 is cosecant x minus sine x over sine x cosecant x. And I'm supposed to get this. Okay, I'm kind of liking this cosecant sine stuff, but I also feel like I better do something with it. This one's hilarious. And that you'd feel silly if you didn't try it, okay? What is cosecant?
1 over sine.
1 over sine. What happens to those?
It'll cancel with the top.
Oh, they just turned into 1. Oh.
And I got it. Did y'all see that?
I liked that one.
Okay? What's gonna happen to your eyes and your mind the more that try, not the more I actually do for you, but the more you try, you're gonna get better and better at it, okay? All right, so what I'm gonna do is, I'll post your homework. You'll do a little bit of what we did in class today. And also you'll have a quiz on, probably about 3 or 4, I don't know how many, verifying identities. Girls, sometime between now and, well, I'll do it before I leave town, I'm leaving town tomorrow evening. But sometime today or tomorrow, I'll make a video of me working all of these, okay? And I'll send it to you. I'll
Thank you
email
so
it to
much.
you and I'll post it.
Thank you.
But try them yourself. However, you may want to watch this video and then I'll give you more to practice on your own.